We'll see about the addressing modes of 8086. So, addressing mode will help us to understand the type of operands we use in instruction and how they are accessed while executing an instruction. So, we have these types of addressing modes in 8086: immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, base plus index addressing mode, base relative plus indexed addressing mode. We'll see every addressing mode with an example. The first one is immediate addressing mode. In this type of addressing mode, the immediate data is the part of the instruction and it will appear in the form of a byte or bytes. So you call a bytes as word, 2 bytes as word. So the example is, for example, I give here move ax comma 10 AB where H denotes it's in hex. So of course we know that AX, it is a 16-bit register where the lower byte is represented as AL and the higher end is represented as AH. And when I execute this instruction, what happens here is the lower byte will go to the AL register and the higher byte will go to the AH register. Now the AX will have 10 AB where the immediate data is moved into the AX. The second addressing mode is a direct addressing mode. In this addressing mode, a 16-bit memory address is used as an offset, which means that this 5000 will be treated as an address. So here I'm not going to talk about any physical address calculation. Just let us consider the memory is addressed with locations 5000, 5001, 5002 for example. Okay. So the meaning of this instruction is after the execution, whatever content I have it in the location 5000 and in 5001 will be loaded in AL and AH respectively. You also see to that, always remember that the lower address content will move to the lower order register and the higher address content will move to the higher order register. So you could see here 22 moves to the AL and 33 moves to the AH. And next is register addressing mode. So in this type of addressing mode, the data will be stored in the register and this can be an 8-bit register or it can be a 16 register. The very important thing you should note over here is the source and the destination size should match. For example, I have given here the move instruction. So it is a data transfer instruction. So BL is an 8-bit, AL is an 8-bit. Similarly, the BX is a 16-bit, AX is a 16-bit. So here you could see here, for example, I have taken move AX comma BX. So what is there? In BX you have 10 AB and when I execute this instruction, so automatically what happens here is the 10 AB will move into the AX overwriting the previous content. And the very important thing to be noted over here is all the registers can be used except instruction pointer. And the next addressing mode is register indirect addressing mode. Here the register will hold the address and the content present in that address will be moved to the destination specified. For example, I have taken here move AX comma BX where the BX will serve as an offset register. And the BX, let us assume that it has the data 5000. And now this 5000 will be treated as a location and the content present in 5000 and 5001 will move into the AL and AH respectively, that is AX. So this moves like this. And coming to the next addressing mode, it is an indexed addressing mode. It is very similar to the previous addressing mode, except that the index register can be used here, that is SI or DI. So the very similar thing. The 5000 content, which is 22, will move to the AL, 33 will move to the AH. And coming to the next addressing mode, it is a register relative addressing mode. So in this mode, the data will be available at an effective address formed by adding an 8-bit or 16-bit displacement with content of any one of the offset register. That is, either it can be a BX, it can be a BP, it can be a source index, or it can be a destination index. And the default segment will be either the data segment or the extra segment. Now you could see here I have written an example move AX comma 50 hex, which is a displacement, and the offset register is BX. So what will be my final index address? So BX is holding 5000. I will add a 50 to it. So this is internally added, which gives a 5050. Now the effective address is 5050. So when this instruction is executed, the content present in 5050 and 5051 will move into the AX register. So it moves like this. And coming to the next addressing mode, it is a base plus indexed addressing mode. So the thing over here is we will be having two offset register. One will be the base register, either it can be a BX or the base pointer, and this will be added with the content of the index register. This can be a source index or destination index, but the default segment will be the data segment. Okay, and here coming here, so I have given an example move x comma bx si, and the bx, for example, let us assume that it is holding 1000 and si is holding a 2000. So final index address will be 3000. Now the effective address is 3000 and the content present in 3000 and 3001 will move to the AL and AH respectively. And coming to the base relative plus index addressing mode. So this is also very similar to the previous addressing mode, except that the displacement will be added along with the effective address thus formed. So here, for example, I have given here move AX comma 50H BX SI. So as in the previous case, the BX is holding 1000, SI is holding 2000. So the effective address would have been 3000, but I need to add a displacement which is 50H. Now the address becomes 3050. So the effective address is 3050 and hence the content present in 3050 and 3051 will move into the AX register. So this moves like 12 goes to AL and 34 goes to AH. So the references I have taken from Advanced Microprocessor and Peripheral by A.K. Burchandi and A.K. Ray. Thank you.